So what I'm presenting here is behavioral mapping done by the use of deep neural nets. And what that basically means is I take a neural net and I show it images, as in images of the game, which in real world would be images from the dash cam captured during driving, and I show it the labels for each image are basically my control inputs, which can be the keyboard inputs, or where's that joystick of mine? The Xbox controller. I had one. I can't find it right now. So yeah, you could use that controller, any kind of controller. The label for each image is basically the trainer's control inputs, right? So in an image, if I press the forwards and the left key, then that's the label for that image. It can have every label image has four labels, and at least two of them are like non-zero at a time. Okay, so what we can do with this is that um, we can run this and the lane detection algorithm at the same time. And if we do that, then it can help us figure out when we should run the object detection algorithm, and when we don't need to run the object detection algorithm, as well as where the object would be in the frame. For example, if the lane detection algorithm says go straight, because the lanes are going straight, but the neural net says go left or go right, then that means that there's something that that needs to be taken care of. As in, there's something that's causing the neural net to try and make us point in the left or the right direction. It could be an obstacle, and that's like worthy of an alert, right? So that's the only time when we want to run the object detection. And it can even tell us, well, like if the lane detection algorithm says go straight and the neural net says go left, then that means that the object could be on the right half of the screen, and or the image, which helps me, like, and then I can sort of just run the object detection in maybe this region of the entire image, and not the entire image, like just one small region of the image, because I already know that it's probably in this region, right? So this is like a proof concept, um, which I sort of created in like 3 4 days, I guess. Okay, yeah. So it's not trained that much. Like, I haven't really trained it. I'm not controlling it. Both my hands are like on my mobile, so I'm not controlling it. Just I just showed you that, and it hasn't had that much training. This is like around 400 seconds of gaming. Like I played the game for about 15 20 minutes, I think. And then you kind of have to balance the data out, and in that balancing thing, a lot of frames get lost, because like half the time you're just going straight, or more than half the time you're just going straight and you're not really turning or anything. So if you had like if all the data just had been sent to the neural net, given to the neural net for training, then it would just conclude that okay, I have to go straight all of the time. So you kind of have to balance the data out. And because of that, even if I play it for like 15 20 minutes, an hour or something like that, it's not going to have a lot of training data. So yeah, it's just like 400 seconds of training right now. I don't think. Yeah, okay, it's visible. Okay. Yeah, it's on the wrong. It's trying to go. As you can see, it's trying to go to the right side of the road, because it has sort of figured out that it's on the wrong side of the road. I hope so. Yeah, it's on the right side of the road now, going to the wrong. But well, it's also looking at the map here, and the map is actually telling it to go on the wrong side of the road. That's just that's just the way my game works for some reason. So the neural net doesn't really can't really do anything about that. The neural net uses the map here, as well as the lanes on the road as guidance. The map in this game could then be replaced by something like Google Maps or something when the person is driving. Okay, I'm just guiding it right now. Okay, okay, hands off. About to reach our destination here. Almost there. Okay, yeah, okay, okay, here. Ah, okay. Right. So, yeah, that's the proof of concept for the behavioral neural net. Thanks.